Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us. Please, can you confirm you can hear me?
Yeah.
Fantastic. Thank you so much. Thank you so much, everyone, for joining us on today's session. It promises to be amazing because we have an amazing speaker joining us today in this session. So, for those just joining us for the first time, this is Mata Microsoft AI User Group, where everything we do in this community is about learning, innovating, and building together. This community was founded this year in February, and our focus as a community is AI, cloud, and DevOps. And the mission for the community is simple: free learning for us, meaning that every session that we organize in this community, they are free. We don't charge. They are actually free of charge. Thank you so much, everyone, for joining us in today's session. So before I actually introduce our speaker, let me quickly introduce myself. My name is Emmanuel Itoje. I'm a Microsoft MVP. I'm also a cloud security architect. I'll be the moderator for today's session. So for today, we have an amazing speaker, like I mentioned, and she's actually a Microsoft MVP. She's no other person than Shubhangi. Thank you so much for joining us today. So Shubhangi is actually our presenter for today's session. She's actually a Microsoft MVP, an amazing speaker, and also an international speaker. Shubhangi, it's good to have you today. Thank you so much for joining us.
Thank you. Thank you for having me.
Yeah, so before you hand over the mic to do, so today you're talking about architecting AI with MCP. What are some of the things that our participants today should actually expect as part of joining to this session?
So, in this session, obviously, we'll talk about Microsoft Foundry and then how you can create Foundry server using Visual Studio Code. And then what are some of the pitfalls that you might experience while, setting up the MCP server. And then essentially, I would say I would give a quick tour as well of Microsoft Foundry to start with, and we will take it from there.
Thank you so much. Thank you so much. So for those that are joining, Shahangi is an award-winning data and AI professional who has worked in a Fortune 500 companies and agile startup. She has a background in computer science, engineering, and with an MSc in business analytics from the University of Bath, UK. She works as a senior analyst at a leading FTSE 100 company in financial services and insurance in the UK. And previously, she has led multiple projects at ICS AI Limited, a Microsoft UK inner circle partner, focusing on artificial intelligence and data at the forefront of technology for the public sector in the UK, especially. And she has spent nearly a decade in data analytics, data science, as well as data strategy and AI, leveraging algorithms to extract insights, identifying patterns, and also understanding human language in large data sets. She leads the London chapter for the Women in Data, which is a platform for tech enthusiasts and also for all backgrounds to connect, to grow, and also to learn together, which is part of our mission in our community today. And she's actually a verified expert and a mentor at a top mate. She has delivered sessions in over 10 countries, and she has also been nominated for several awards, including a Women Tech Network Global Award. Thank you so much, Johangi, for joining us today. So we're handing over the session to you so you can have the floor.
Sure. Thank you very much. I will just share my screen first. 1 second. Can you see my screen?
It's coming up, not yet. Yeah, I can see it now.
Okay, cool. Right. Firstly, thank you again for the warm introduction. I'm really glad to be a part of this user group and to be able to deliver this session. Um, I will start the session by giving a quick introduction about what my model context protocol is, and then we'll go through like Foundry and what does Foundry offer, and then how do you build like a Foundry MCP server, and from there we will take it to the next level. So obviously you have already received my introduction, so I'm not going to add too much, but just a couple of lines. So as said, obviously I work as a senior analyst at a leading FTSE 100 company. I'm also a Microsoft MVP, and I previously spent most of my career working at like an AI projects, previously at an AI startup. And then before that, I was at Tata Group, where I was working both as a data and AI consultant. Um, And I also obviously lead the Women in Data London chapter, where I support other women in tech who want to build their career in this space. So to start with, I'm gonna start with talking about what MCP is. If you have any questions, by the way, please feel free to drop those questions on the chat, or you can ask me towards the end of the session, whichever way you prefer. So when we talk about MCP, like MCP came a couple of years back and it became quite quickly very popular. MCP is a standardized framework that enables our AI applications to connect seamlessly with external tools, any kind of data sources or systems that you might have, which basically helps them enhance the capability and the interoperability from one to another. So for example, you can think of this like, if you have AI applications like Claude or ChatGPT, they can connect with different data sources. Like, for example, if you have local files or databases, or if you have tools like, search engines or calculators, it basically is able to, connect all of them together, access any info that you might have available and perform tasks. I would say you can think of it like a USB-C that basically work as a standardized way to connect with electronic devices, any kind of MCP providers, or any kind of AI applications to connect to the universal, different systems, I would say. So it's pretty like in a way like a universal thing that helps you or facilitates seamless connection across different platforms or different sources that you might have. To understand MCP in more detail, think about these three things. So first thing is like it's standardized, which means like there is one protocol and that one protocol is able to connect to many different models or any tools essentially. So you don't need custom integration. So if you have worked obviously on development projects, like I've worked on several, the biggest problem we normally face is like we normally see like a lot of custom integrations have to be built to connect one system or tool to another. So that basically goes away and it makes it more standardized to connect one to another. Second one is auditable, because in this one, every tool call that you make is explicit and it's traceable. There aren't really any kind of like hidden side effects, which means there are no unknowns or less unknowns, I would say. Normally, it's quite hard to track, like if you have written a tool call, what's happening. Sometimes you might not be able to find the right error. In this one, it's actually pretty straightforward to find, like if there is a reason for failure, what you will do and what will be your next step. And then the last one is composable, which means like you can mix and match tools. Like, if you have memory stores, external systems, and any kind of modularity. So essentially, it's very composable. So I would say for me personally, the thing I like is like every tool call is really explicit, observable and traceable. And there aren't any kind of hidden side effects, which actually is like one of the top, I would say, reason why you would want to prioritize or you want to use MCP for some of your applications when you're building it. From here, let's talk about why does it matter. So we talked about what MCP is, what are its sort of like reasons why people prefer MCP. But the main crux of the question is, why do people want to use it? Like, what's the value for them? So let's think about three main things when we talk about MCP. So the first one that we have is developers. Obviously, developers, like everybody who is an engineer, AI engineer, developer, data scientist in some capacity, like they are building applications day to day. It's a part of their day-to-day job. MCP basically reduces the development time because it reduces the complexity that is needed, like when building or integrating with it. So essentially, like any kind of application that you create, the development time goes down pretty fast, simply because you don't have to build any kind of custom integration. Second one, if you talk about is AI applications, which means like access to any kind of ecosystem of data sources, tools or apps, which will basically enhance capabilities. It essentially improves the user experience, which I think like a lot of times people build applications, but they don't necessarily think about like how does it improve the end user experience. So because you have an access to the entire ecosystem, of different data sources, it really makes it seamless to connect from one to another. And then lastly, obviously the main thing, which is our users, who can be our customers, or who can be somebody who is like really, really like you can think of somebody as like a B2C or a B2B customer. It results in more of like a capable AI applications or agents, which can basically access their data and then take actions essentially on behalf whenever necessary. So that's why MCP becomes like a key component when you think from the lens of developer, from the lens of building like an AI application, or the lens of basically having an end user in place. So this is why people, like a lot of people are super keen on using MCP a lot of times while building their application. Now to go further, let's talk about first example. So I'm sure everybody on this call would have already heard of Claude. And like MCP server can actually be used with many different applications. So for example, if you want to use MCP with Claude, what you really need to do is just make sure that you add this to your configuration. This is an example for building an MCP server with Claude. So essentially here what happens is like this is your MCP config, essentially a file that sets up 3 servers for your AI agents. So if you see the first one, we have a memory and we give this command like npx. So essentially each server runs as a local node.js process via this command npx. And together they are able to define what tools and resources your AI agent is essentially allowed to use. So these are your arguments. You provide like your detail and you provide your server memory path essentially here. Now, in the second part, you have a file system, which is basically like we provide details about your file. So here, if you see the commands are same, the npx command is going to be same because here you are still going to call a node.js process. And in the bottom section, you have to just specify whatever your file path is. And then the last one is essentially GitHub. So in this one, you have to provide the environment variables for GitHub personal access token and then provide whatever your token name is. So this is an example of how you write an MCP config file that sets up 3 servers that your AI agent can connect to. First one, this one is for memory, which is for storing and recalling info. Second one is file system, which is for reading and writing files in a specific folder. And this third one is for GitHub, for interacting with any kind of GitHub repository using a personal token. And the token that you have, your personal, has to be specified here. And these each 3 servers, they will run, as I said, through a local node.js. This is one example. Obviously, you have to just replace parts of like this config to make sure it works for you. And you can use this with Claude. So this is really the first example. But the main goal of the session is to show you using Foundry's MCP server. Now, let's go a bit more from one step to another. So normally when developers build applications, right, what happens is like we have, for example, a unique API 1, 2, and 3. So we have 3 different APIs. And like we have to create custom integrations for each of them. And then, for example, here we have a large language model. A large language model here could be your ChatGPT, it could be your Claude, it could be Gemini, it could be anything else. So you have your large language model here. But now when MCP comes into place, essentially what you just need to do is like you have to connect all these 3 unique APIs that you have available to your central MCP system. And then basically this MCP system creates a unified API, which basically goes to a large language model. So you can see the difference from here to here. Ultimately, like this time that you use essentially to build these custom integrations for these APIs gets saved, and you can just connect it to MCP, which acts basically as your point of control, where like it can connect to whatever large language model you can. So you can extend any kind of sources here. It ultimately will help you to like build applications quite faster. Now from here, I'm gonna like take you to the architecture of MCP. So the architecture of MCP like obviously has different parts. So generally you will have a host, which is basically sort of called an MCP client. It could be any kind of IDE, or it could be Claude, or it could be anything else. Now here sits MCP servers, which is basically, let's say you have n different servers. So this is your server A, server B, server C, and here basically MCP protocol particularly sits. And then if you think about data sources, for example, you could have SQL Server, you could have some file storage, you could have some like other repository. So you can have different data sources. This is your data source A, this is your data source B, and this is your remote service C. All these 3 different data sources basically connect to the MCP server, and which ultimately gets called into like your host client or your MCP client. And that's why MCP architecture like looks, I would say on the top level looks very simple, because like it basically encapsulates like a lot of those things. But like in normal development process, obviously like these things are quite like I would say separated, and you have to build like custom things for each of them to work. So that's why people are like super keen on using MCP a lot of time when they're building applications. Now from here, let's talk about the components of MCP. So components of MCP: host, client, and server. These are the 3 main components, which if you remember, we saw here. This is the client, right? And this is the server. And then this is basically going to be your source. So these are 3 main components. But what do they really mean? So first, let's talk about the MCP host. So applications that house large language models or LLMs themselves, they interact with users and they initiate any kind of connection. So it could be your Claude desktop, it could be your cursor, it could be really anything. So any application housing LLM is basically your MCP host, right? Then the second one is MCP client, which basically means like you have integrated with host application to handle your connection with this MCP server. That really means that the host requirement, which is your LLM or your Claude desktop or any other platform, and the MCP. So clients are built basically into host applications like MCP client inside Claude desktop. So essentially, it's really important to understand that I think someone's mic is unmuted. Okay. Um, so this is the second one, which is your MCP client. So you have to understand that there is a host, there's going to be a client, and the third one is basically going to be a server, which is basically something that sits between the two. So this server is responsible for adding context, capabilities, and exposing any kind of specific functions through MCP. For example, it could be GitHub, or it could be PostgreSQL, or it could be something else. So these are the three primary components of model context protocol. And a lot of times I've seen people also classify this into components. So I have added this one. However, like this is probably not the top one, but one of the layers I would say. So this is the transport layer. The transport layer, as the name suggests, is basically a communication mechanism between your client and server. It supports two different methods, the STDIO method and the HTTP plus SSE method. So these are the two ones it supports. So STDIO basically stands for standard input output, which means any kind of local integration that you build, the server runs in the same environment as a client. So they both run into the same like same environment, the same tenant essentially. And this is the one we're also going to see. I think this is the one we're also going to discuss a bit more in detail. So these are the three primary components of MCP. So no matter whichever application you build, the top level components remain the same. Obviously, the versions of those components might change. So you might have LLMs or different LLMs as host. You might have different clients, or you might have different servers. But ultimately, like on the top level, there are the three main things that encompass and are basically called as MCP. Now, how does our LLM interact with MCP? So let's take an example first. So if you see on my screen right now, there are 5 different things. So this is the user, this is your large language model, this is your MCP client, this is your MCP server, and this is your system. So right, there are 5 things. Okay, now see this scenario and understand. So let's say I am this user and I ask, for example, how is the weather in SF? This is my question. Now, when I ask this question, what happens is like, to get that information in real time, it needs to find external data, right? It doesn't have any information. It cannot tell me at this point what is the latest or what is the most current weather in SF. What's the temperature? Is it humid? Is it hot? It cannot tell me anything. So it goes and checks the need for external data. So we try to figure out if this query needs external data. Now, if it checks this, it basically goes and requests MCP capability that, hey, find me this data. Do you have it? So it establishes the connection, and in that connection, they do like they do like that tool call where they are able to get a return answer essentially that, okay, I found the details in a real-time system somewhere that the SF has this weather at this point in time. So here what happens is like it queries the external system and returns the data back to the MCP server. Now, this MCP server has received this data. It basically starts returning the result. So it will start returning the result back to the MCP client. Once it goes back to the MCP client, it basically gets passed to the LLM. So now LLM has its own thing and it also gets an external data. It has two things now. And at this point, LLM is basically able to provide me an answer, which is basically what is the latest weather in SF with the context of which I would say, which is more relevant or in the latest form. So this is how it works with large language models. And this two signs that you are seeing here, which is basically display permission request or provide permission, these two in like the gray arrows, they essentially are like like the tool calls sort of permissions that you have to provide for this movement to happen. Like this permission request that users info goes to LLM and then it gets passed to MCP and so on. So essentially, no matter whatever query you ask, it doesn't matter. It's about asking like, what's the weather in SF? You could ask what's the weather in Malta right now, or you can ask what's the weather in London. It doesn't matter. It has to still get that information. So this process is going to run again and again. So this is how your large language model works in correspondence with your MCP. And it's like it has these main 5 components that makes sure that every single step from one to another actually works really well and in coordination with one another. Now from here, let's go to the next one, which is like the data layer. But before we go to the data layer, let's see some examples. So I'm going to switch my screens. And if you see my screen right now, this one. So this is Microsoft Foundry. Okay, and I'm going to show you an example of Foundry, how to establish a Foundry MCP server. But before I start that, I just want to give a small walkthrough of what Foundry basically is. So Foundry is basically like sort of like an enterprise platform. Like it helps you to build a good grade of, I would say, AI applications. It facilitates any kind of engineers, developers who want to build agents, for example, or applications using different models. Now, on my screen, you would be able to see different models available. So the uh, this one, for example, is in model leaderboard. So you can see different models based on quality, safety, cost, throughput. So when you start building any application, it's really, really important to understand that you should know which models you should be using. A lot of times, what I see is like people build application, they don't know why they picked a model, or they probably will pick a very expensive model, and like their budget of the project is probably very less. So be very mindful of which model you want to pick, and like what is the key areas your application really caters to. Are you really, really looking for something which has high quality answers, or looking for a model that gives you better throughput? Based on that, decide. And then if you see here, there's like lots of models here that are currently available that you could use. And you can see, I think it's 189 right now. And if you click here, you can compare one model with another. So like, for example, today if I select general knowledge, it will give me this sort of like a scatter plot where it will show me which model is better than the other. So it basically says that O3 is like the better model, or it will show me on the top, for example, Opus 4.6 is having like a benchmark score of 269. So it basically gives you all the criteria you need to remember to understand which model to pick. Now, for example, if I talk about question answer reasoning, again, which is probably like useful in those areas where you want to build a model or you want to build an application where reasoning is needed, that kind of logic is needed. So you would want to pick a model which is really good at question answering, or if you want to use it for coding as a coding assistant. So which model is great at coding? So you want to see, okay, maybe GPT 5.4, maybe 4.6. So the quality index is high, you can see here, or you would want to pick, for example, GPT 5.5 or 4.5. So these metrics help you to assess which one is going to be the right fit. So if you haven't tried it out, I would say log in into Foundry and try these things and check like which best meets the need for the business scenario that you're really catering for. Now let's go back to my screen. And this that you're seeing right now is the older version of Foundry. So you can just click on this toggle and it will basically take you to a newer version of Foundry. And there are so many things. For example, there are playgrounds here. So if you want to explore something on playground, you could pick it from here. For example, this is a language playground, and it provides you like a lot of LLM powered natural language processing capabilities. For example, if you want to see language background, you could try using sentiment analysis here and take, for example, like a sample of data. And if you run it, it will give you like details and output of like how each of these lines have different sentiments from one to another and so on. So I would say go and check it out. But obviously, this is not the scope of this talk. I've just shown this because this will lead into the MCP server. But yeah, please go and try it out before start building the MCP server, I would say. So now let's go to my VS Code screen. If you see my screen right now, I've shared Visual Studio Code, and on my screen, if you see, I've created a file called mcp.json. Now this file mcp.json basically contains my code that will be basically used to like create MCP server. So normally, like what you would do is like we are using the stdio method, which I think I showed on my slide, couple of slides back, and you essentially provide like arguments around like for example, what's your Azure search document details, or for example, like you have to provide all these details around your Azure OpenAI endpoint, your API key, or for example, your deployment keys, and then API version and API project endpoint. So you will need these things before you start building it. So make sure when you start building your MCP server, you have these details ready. I have used the environment variable here in which all these details are kept. So this is the file that I have. If you see, I've pointed it here. It's also sitting in my MCP folder where basically the actual details of each of them are currently sitting. This I've done because I just want to make sure that my API keys are not like visible just in my script. And like you should also ideally, I would say, make sure that your API keys are not visible whenever you like either show it to someone or like if you're actually writing a piece of code. Then if you go downwards, you can see, for example, I've given some input examples, like for example, uh, some IDs and prompt strings to make sure that it's testing for GitHub tokens or Azure AI Search Point or the API versions, for example. And if you see that the parameters and the fields are pretty much same across the board. So there is ID, there is type, there is description and password. And like there's a bunch of those examples. For example, there's Azure tenant ID, there's Azure client, and so on. So this is, I would say, pretty standardized. So once you create one of the scripts, you can actually like use part of this code, like, but just make sure you use the right description, right password details, and right type for each of them. Now, normally what you would do is you will check here. So you will see this option here, which is like MCP add server and MCP list server. So if you click on list one, you will be able to see if we have any currently like, active MCP servers or not. And if you like go here and if you check add server, which means like you could create a new one if you need one. So this is how like you can start to build MCP servers on the VS Code, right? So for example, if I restart it, so this is the one I had built previously. So if I restart it, basically starts running. It has 45 tools, 19 prompts. It will start running in the bottom. You can see like it starts to put like some details on the bottom to show like what's happening. And each of these steps that you get, you can basically trace it. And it basically gives you all those details step by step that's happening one by one for like each of those files. And the interesting bit is like you can also open this in agents. So once it's running, it basically starts to create like this small agent screen, and like it will start basically becoming sort of a like personal assistant in this particular session. So this is how you can like create the MCP server using like Foundry, and you have to make sure like you have the right environment variable set up to make sure that it works effectively. So the main bit really is to ensure that you have a name for a server, and you have, for example, your API endpoint key set up, and like that, basically some sort of like input variables for each of the GitHub tokens, for Azure AI search point, and so on. And you can use Control Shift P from your keyboard, or you can also directly click here and see all these things. For example, if you want to see the list servers, like for example, I've created 3 of them, 2 of them are old and then one was new. You can see all of them. Or if you want to, for example, add a new server again, you can use same. You can see there is an option for HTTP one as well. And there is a bunch of other ones which you can also create. But we are using the STDI one. So if you see here, there is an STDI one which we have created. So you have to specify the type of the server that you're currently using. All right. So from here, let's go back to my screen again. And I'm going to show some of the other bits. So let's talk about the data layer. So now I've talked about like what MCP is, why do we need MCP? Then like I've given you a small insight into like what Foundry is, and then how do you create a Foundry MCP server? And in these 4 things, there's one other thing which comes after that, which is basically your data layer. So now let's say you have built your MCP server, right? You still have to think about like how data gets used and how data layer gets built. So in that, there are 4 main things. First is initialization, second is tool discovery, third is tool execution, and then fourth is real-time update. So when we talk about initialization, MCP begins with lifecycle management through, for example, capability negotiation. So the client sends initial requests to establish a connection and then negotiate supported features. And then there is a tool called discovery phase, which is basically the MCP client is able to find a tool list or tool request, where it basically runs an entire mechanism. Once that tool discovery is done, then you basically have a tool execution process in which basically you demonstrate how MCP primitives are used in practice. So essentially, like the client invokes them with appropriate argument. And then last step is real-time update. So if I'm asking any query which requires real-time data, it needs to be like explicitly requested to the like it should be explicitly requested to make sure it provides, or the data is essentially provided. So the another way of looking at that is this one. So if you see this one, it's pretty much the same thing. The data layer is sort of parallel to what we saw in this one. So we have, for example, initialization phase. This is sort of your initialization phase where like that whole setup is happening. Then you have a tool discovery phase, which is basically this area. So here the LLM sends a request, the request goes to MCP client, and then it goes to server, right? Then the third one is execution phase, where it turns that request into like a tool call method, which basically happens here. And there is a last step, which is essentially real-time update, which is like this external system supplies of information. So this fourth step is sort of parallel to how LLM interacts with the MCP, right? So this is how like in 5 different ways of 5 different like points, you can imagine like how LLM actually interacts with MCP. Now from here, let's talk about more details in like tool call request and tool call response. So tool call request and response is basically this one and this one, these 2 things. So in this one, what happens is like normally, for example, if you take a same example of like finding the weather of SF today, let's say at this point, right? So what you would normally do is you will create a JSON RPC tool call request, and then you create like a method, which is sort of like a tools or call. And in those ones, the parameters that you will give is name. So you will provide a name, for example, weather underscore current, or you could provide any other name. It doesn't matter. You can choose your own name. And in arguments, you will provide what location essentially like you're looking for, or I would say the tool call will basically pick up this location. So you can have any location here, and then in what units you would want that tool request to be, right? So once that tool request goes, then you have a response available. So the response is here. So here again, if you see, there is same ID, there is same JSON RPC, but the content is different. So it basically returns a content in type text. It gives you the current weather, for example, in this city is this, and it gives you more details about like, is it cloudy or not cloudy, and so on. So what it does is, this is the request, this is the response. So this is how the process works. You request something and you get a response for something. And in the bottom, if you see, there is like a pseudo code for this AI application execution, which is like you have a asynchronous like tool call where like you provide conversation name, tool name, and argument, which means like if you have a session, you essentially provide like a tool name, and then there is a result variable that you create, which basically gets a session call result. And this conversation essentially keeps on adding the result and the basically the content it gets from that result. So when a language model decides to use a tool call during a conversation, the application intercepts that tool call. It routes it to the right MCP server, and then it tries to execute it. And once it has executed, it returns back to LLM as a part of that whole conversation flow. What it does is it enables a large language model to access real-time data and perform actions in the external world. So in summary, this is the request, this is the response, and this is kind of sort of like the intermediate process that happens where like the tool call is basically being handled. This is how you will structure, like if you have to, or you can imagine it gets structured when you request something like on your tool call and when you expect a response. Now, I want to give some more details around like tool call discovery response. And this is basically also from, I think, some of my previous projects I've done where like somebody asked me these questions. So I thought I will add these slides into this one. The first is like, if you think about tool discovery response, there are four main things, right? Your name, your title, description, and schema. These are the four main things you will have. So your name is anything. It's a unique identifier, right? It is something within the server's namescape. So you can provide like this as like a primary key sort of for your tool execution. But I would say it should always follow a very, very clear naming protocol. Like uh, you can write something like this. If, for example, you are making a tool called calculator, right? Don't write just calculate, please. Write like calculator underscore arithmetic, because if you don't write proper like identifier name, it's sometimes hard to interpret and like understand. Second is title. So, for example, when we talk about title, a human ready display name which can be simply understood would be great to have in title. Then description can be any detailed explanation, for your tool call, what it does, and so on. And the last bit is input schema, which for me, I would say is also one of the very important part. Like there's generally a JSON schema that defines the expected input parameters like type validation and clear documentation about required or optional parameters. So essentially, this tool discovery can be something like this one, where you have some parameters. Just make sure you have the right parameters available for request and response. Then some issues you might run into, which I've seen a lot of people do sometimes, is like, firstly, like when you do this, validate all tool inputs against a strict JSON schema. Like don't just pass wrong string, because it can create several issues. So validate, have a process to validate every strict JSON schema, like maybe have a review process, or maybe like, have a checkpoint process where you can check how the schema is written. Is it right or not? Like, is it allowed to be passed through? So make sure those things are done. Second thing is like treat tool request as untrusted data, which means like before you send them to the model, right? Make sure you sanitize them, because it's not structured. So make sure they're structured before they go. Do not just put like any tool call into that. The third one is like audit all outbound calls, which means like implement any kind of allow list for external endpoints, log tool calls. So make sure that you audit all these outbound calls that are happening. The fourth one is apply least privilege per tool. So sometimes what happens is like every person has same level of privilege, and that creates really problem because each server exposes minimum required capabilities. So apply least privilege on every single tool call that you do. And then lastly, set hard limits on tool called depth or token budget. Implement circuit breakers wherever necessary. So these are the five main issues and the way you can solve them. If it happens to you, it will really save your time because it is a very, I won't say there are like too many things you have to do. You have to just remember that these are small things that can create challenges in the long run when you start building, and then you have these tool calls that you run. So hopefully this will help you like skip some of those issues that you might face early on in your process. So let's talk about in more detail about Foundry MCP, which I showed in the VS Code. So first things first, this is how your JSON looks like. So there is gonna be a server tag and there's gonna be a name. So you can name it anything else as well. You don't have to name it the same, but there's gonna be a type. So make sure you know the type, what type you're gonna put. Is it stdio, is it http, what type you wanna have. And then some URL. For example, you can use this URL to create a new one. So for this to happen, as I said, install Foundry MCP server in your user profile. So it's available in like all VS Code. And you can use this keyboard shortcut like Control Shift P. So what happens is like it will open like the command palette for you. And when you search for MCP add server, which I showed I think in the start, you can select whatever option you want, like which kind of server you're trying to build. You enter this mcp.ai.azure.com as URL, and then you enter your name, whichever you want. So just to quickly revise this thing, if you see this screen here, so I've just pressed Control Shift P, and then you can see MCP add server, MCP list server. If you add a server, you can basically select either HTTP from here, or you can use that URL mcp.ai.azure.com to create a new one from the scratch if you want to. Now, from here, what you have to do is like the MCP config that you write, which I showed again, but I'm going to explain in more detail now. The first things is like where it lives, where that config has to go. So this is your project, right? Your project name, whatever you want to give. And this is basically your VS Code file. In this one here, you create mcp.json file and your environment file, which basically contains all your API keys, that I showed, 5 API keys. They should sit in your env file. And here on the right, if you see, this is the final working config in which like, see on the top, you have servers, then you create a name for your server, whatever, like could be Foundry MCP1, any name you can give. You can give the type, for example, here there is stdio. You have to give like where your file sits. You will need this file uvx.exe. And then here you have arguments, for example, your Git path, and it will require your Azure search document value. It will require your Azure AI Foundry server value, and then environment variables here. So the key fields in this one is these four: the type, whichever you give, the command, which means your full path that you need uvx.exe. Then the third one is your arguments, which means it tells this file uvx.exe to install and run. And then there is your environment variable, which is your Azure credential passed securely. So these are the four main key fields you will need as a part of the final working config. Now, what errors you can get in this phase? So for example, this is like, if you see this one, so this is the same thing that I showed. So you basically have your server name here, you can have your arguments here, and then you can have your environment files here. But the bigger thing is like, even when you run this thing, you can run into several issues or several errors, which are almost like, I would say they happen all the time. So some of these errors, which I am telling you on the screen, which probably you can skip if you get into this trouble, is like, firstly, 401 is a very common error. This means that your HTTP endpoint requires authorization, and it's basically switched to some other mode with API key in the environment variable. So you can solve it by making sure that it does not switch into some other modes. It's in HTTP, it should stay in HTTP endpoint. The second one is this one, in which you can get this error where your UVX file is not working. So which means your VS Code could not find this file wherever it has been placed, which means the path is wrong. So make sure you have absolutely full path you have written for this file to work in your mcp.json file. Third one is your Git operation has failed, which normally means that Git was not installed. And it was not downloaded and it was not installed for Windows. So this is a common failure. A lot of times you will miss. Then this one is very common, module not found error, which means like you add this with your Azure search documents and you give this in your arguments array. So essentially, uh, so you see this one, Azure search documents, you give this value here. Do not skip this value. You need that value. And next one is platform broker error, which means like disabled Windows, essentially like your Windows has stopped working. So make sure that in your configuration, you set as your config value as false for this one, for enable broker on Windows. So these 4 or 5 errors are very frequent and common. So make sure that you're able to identify these errors and rectify them before they actually become like they actually happen towards the end of the cycle. Now, how will you secure your API keys? So this is also, I saw some demos earlier. I think some people asked me that, how do I do that? So obviously I did mention this before. Hard coded keys in MCP JSON are really visible to everyone. And it's not a great idea to do that. So create an ANV file. This is the way I have done it. And maybe add all your API keys there and then reference that file into your mcp.json and then add .env to this file, git.ignore, which means like the version, this file will just get on the side, like it will not be like a big problem. So essentially like what you do is like this bit that you have here, .env, is where like everything is there. You don't have to write the original values in your mcp.json file. You can just put it there. Now, once you have built the Foundry servers, how do you test the Foundry server like using this MCP? So what you can do is, this is how I generally like to like test it. So you can open the GitHub Copilot chat panel and you can confirm that the agent mode is selected. And then you can enter the prompt that uses, your Foundry MCP server that you have built. And like you can ask questions, for example, tell me the latest models about Foundry or any other questions you could ask. Like these are some of the examples. So these are some of the like examples you could use to like test that your MCP server is up and running. So normally looks like this, like you will have, for example, a model catalog and benchmarking data available. And then you can like once your Foundry server is up and running, you can basically make sure that it actually works. It's just not, failing at some point. So these are some of the sample prompts. You can try other prompts, obviously, but these are some of the sample prompts you can use. They help you to make sure that your server works effectively, that it doesn't have any sort of error. And, like, for example, it can also give you reliable output. So make sure to test, for example, with some of the prompts on the MCP server. Then the next bit really is how do you troubleshoot. This is a very important bit again. So in troubleshooting, for example, if your server does not start, make sure that you enter this URL mcp.ai.azure.com and you run list servers to check the status for that. You can do the same, this again, like here, you can like just like use this and you can check it here by pasting the URL here that your server is up and running or not. Now going back here, second one is authentication prompt does not appear, which means like you have to make sure that GitHub Copilot extension is installed and you are signed into VS Code with your Microsoft account that has your Azure subscription. So if someone doesn't know what Azure subscription looks like, so this is, for example, Microsoft Azure, if you see on my screen. Now this is your search service, but like you could also have your subscription account here and you should be able to use that, for example, for your Foundry project as well. Then Foundry tools do not appear in agent mode. So you can confirm that the server is running. For example, there will generally a green light available. So that makes sure that your Foundry tools are actually working in agent mode. And then last bit is access denied or permission error, which means like verify that you have contributor or higher roles in Foundry projects. The server basically uses that on behalf flow with your intra IT credentials. These are the 4 main things you could do if you run into any of these extra errors as well. So to remove any kind of server config also, the bottom bit just to like highlight is like, make sure that you delete the server entry from VS Code in your project folder as well. And then like run the entire server again. So if you have any issues, remove any older version, create a new version of the server and then run it again. So normally it just works fine with that. Now, some bits for the reliable MCP deployment. So it's good that you can run a version and make it work, but there's some things you should remember when you're doing reliable deployment. So first thing is connection pooling, which means like maintain persistent MCP server connections rather than spinning per request. That's the first thing. Second thing is async tool execution, which means like if there's a long running job that you might have, you should make sure that you have a timeout for at some point, like like return that job ID immediately and poll for results, because there is no point of like running a long job if it's not like working well. Then the third one is caching tool result, which means like you cache any kind of deterministic tool outputs like static lookups or any kind of TTL based invalidation. This basically cuts your latency and the API cost very dramatically. Then the fourth one is rate limiting and back off, which means like implement per tool rate call, which means like at the MCP client layer, uh, like make sure that you're implementing rate limits as per tool calling that you're getting. So this essentially like creates exponential back off with like any kind of transient jitters you might get. Then the next one is health check. This is more like, I would say, like caution rather than like sort of reliable. It's like ping your MCP servers on a heartbeat. Like, for example, if it goes down, like surface if there's any partial capability to work with an agent. And then last one is observability, which means like trace every tool call. Do not skip it. Trace every tool call with your IDs, any kind of log inputs, latency, errors, whatever you get, it's fine. Just make sure you have complete visibility and use structured logs if needed for altering any of these. So these are some of the things which will really help you to make sure, like when you deploy these things, if you run into these errors, you can just, solve them quite fast, or you can like at least have like a solution ready and you don't have to spend several hours figuring out how do I solve this deployment. So now next one is some bits around like towards the end is about AI systems. So now we have discussed about like what MCP is, but like AI systems now, they can basically plan, they can use tools, they can maintain memory, and they can like give examples of multi-step actions. So in the next 2 3 slides, I'm just going to talk about context engineering, but I'm not going to go into detail, just very high level, and like how it sort of connects with all these things together. So now, the important bit is also like these four things are already a part of your system. That goes without saying it. But these things have also become sort of like system engineering. So the real challenge right now is not just building intelligence, it's about context management. So you have this data available. How do you manage the data well to make sure that your agents or your AI systems work effectively? Now, what happens normally is like when people build agents or AI applications, they just plug in all the data. We think that the like large language models is capable of just taking all the data in and working well with it. But context is a very finite thing. Like LLMs have very hard token limits, and then the long sessions that you have, they lose early context silently. Like they lose it, and it doesn't work that well. So it's really important that you make your context effectively. Then make sure that every conversation starts blank, which means like no, every conversation actually starts blank, which is a problem because it doesn't have any memory of the past interaction. Now, you have built an enterprise scale agent. Somebody is looking at your enterprise scale agent and thinking in your head, oh, why does this like not give me right outcome? Yes, because it has no memory of it. It doesn't remember who you are, or what did you ask about before, right? Any information available is no longer provided. So make sure you have a memory. There's a persistent storage, which could be summarized form, which could be like a small memory, which knows that who the user is, what they ask, and so on. Otherwise, it's just really not reliable. It's just not gonna be something you can scale in production. And third one is tool chaos, which means like any kind of ad hoc integration that you get is fragile, inconsistent, hard to audit. So make sure that the tool call, as I said in the start, is like logged. Every single step is logged. And then the last one is external systems. So connecting to APIs, database, any file system requires like any sort of bespoke glue code. So it's really important to make sure that any kind of external systems that you build, they can be connected from one to another. So this is like I would say a context problem, which is which I've seen quite frequently in most projects with people work on. And then like what happens normally is like they build everything and then they can't make it production ready. Like it just sits in like development, and it's a problem because you've spent so much time, so much effort, you've used the right approach, but you cannot like take it to the next level. So like these things have to be thought of before you start building your entire application. Then some last bits about memory management. So if you think about, like context, it's also important to think about memory, because without memory, your application, your agent, or whatever solution you're building cannot remember anything. So whenever you have the first interaction, like it stores that bit that okay, this user has asked me about this thing before. So every request arrives, if there is no memory, like a first interaction, like it doesn't know anything about you. And then the users have to specify every single time their preferences, what they are looking for. And this could also lead to a very frustrating user experience because they must reestablish that kind of, what I'm looking for with like this agent, or what are those interactions is going to be about. So make sure you understand that when you're building an agent or application, you have the right memory. And in memory, for example, in terms of MCP, you can store directly the data in your MCP server using dictionaries, objects, or variables. And the reason that works well is because fast access, obviously, there is no external dependency, it is simple to implement, and there is good session data. But these things can only be done if you have this in place. So make sure that you think about, am I building a voice agent which needs to store more information? Am I building like a chat agent or a coding assistant for myself? So you have that thought before you start building it. Then some common pitfalls to avoid. So the first one is like only expose what agent needs for its task scope, which means like if you provide more tool details, there is more confusion, simple and square. So it is no guarantee that large schema will solve that problem. Second thing is descriptions are the model's interface contract. So be precise about your input, output, and what to use. Very, very precise. Do not add too much information in that. Then define what agent should do when a tool fails. Should it retry? Should it escalate? Should it degrade? What should it do? So just mention it explicitly. Like, do not expect that agent should know everything on its own. So model it explicitly. Then the fourth one is like long tool calls that you have, very, very long tool calls, install everything. So use async patterns or timeout or streaming with the protocols, they have to support it. And then last but not the least, large results load context. So I have said this a lot of times, I think already in this presentation, but if you have too much data in your large language model, when you're building this application, even with like having MCP as well, it can bloat the outcome. So always, process, filter out, summarize, and make sure that only necessary information is passed on to the large language model. And like it actually gets filtered down before the model sees it. So with that, I'm going to cover some final key takeaways of the session. So the first one is about like MCP really is an interface, which means like it standardizes how models talk to the world, not just within them, within the application. So the complexity is still sitting within your architecture and tool design. Then the second thing, which I always emphasize, is security is non-negotiable. So every tool that you have should be very, very sanitized. It should be checked, validates every input, and apply least privileges by default. Do not give higher privileges just because it's needed. Make sure you give least privilege and then increase step by step. The third thing is, if you are building an application, there's some point in the process you will have this problem that your context is gonna load. So context is a finite resource, and I would say it's a precious resource as well. So treat every token like it costs money, because it actually does, and manage that context budget very, very explicitly. Then the fourth thing is, tool descriptions are your interface spec, which means like you write them like you write API documentation. It's not like code comments. So the modeler reads them and then they decide what to do, what to not do. So be very, very specific. And then last thing is observe everything in production. So if you have built something already and you feel it's great and you are production ready, then trace tool calls, log latency, alert any kind of errors that you might get. Because if you are not tracking these things and it's running on its own, there is no, then basically like it's not responsible to build a system like that. So it's really important to trace all those steps to ensure that it's like, reliable and trustworthy for the users. To ensure like it doesn't get like it has some issues, it actually flags those issues to you. It's not just bypassing them and running on its own. And I think with that, my session comes to an end. If you have any questions, I think we have some time left, I think 5 minutes. So feel free to ask.
I have a question for you. Thank you for this presentation. It was very good, simple. My question is, what did you build agents on production now, and it's working fine? What's the best practice for building some agent in production? And also, what's the tools do you use for building agent, like long chain, like graph, bindenting, all, and also what's type of cloud you use for deploying all this your system? Thank you.
So, firstly, good question. So, obviously, LangGraph and LangChain is what we currently use. In terms of best practice, actually, I can show 1 second. Screen.
So, do
So,
you
if
recommend the long graph or long chain or bindenting?
Uh, I think I'm not saying, see, I'm not gonna pick one of them. You can pick whichever you want, but I currently use like LangChain for most of my like building stuff. And like in terms of the best practices for building agents. So I just want to show something, if you can see my screen still. So can you see my screen?
Yes, I see it.
Yes.
Yeah. So yeah, okay. So this is like, I've been using like a few tools to build it, but I'm just gonna give like some examples in respect to Foundry. So in Foundry, like, so normally what I recommend is like you're building an agent, right? For example, this is a sample agent, so don't take it like as a production ready. Like production agents are slightly different. So like see this one, like this one I've taken like a model. So I take a model which I can, fine tune, or for example, I can build like a drag application on. And because I have a lot of historical data available, or I've collected all of historical data. So I use like a version of the model which caters to that need that, okay, I have these 5, 6 things I want my model or my agent to basically answer. So I will try to ensure it's very fine-tuned, or it like basically gives all the right answers. And then I think it's really important to give like sort of like right instructions so the agent knows what the goal of that agent is. So, and for that to happen, you have to write a really good prompt. So sometimes I think somebody asked me this question, they don't know, for example, if they have written a good prompt. So you can, like, at least in Foundry, you can do that. You can optimize, you can give, like, for example, I'll give you an example, for example, okay, provide. So let's say you don't know how to write like a good prompt as an instruction. So you just like optimize it. So it's just gonna optimize that whole instruction for you. So you just write whatever keywords you need and it will create the one. And it will also show you reasoning if you want to see. So let's say I click on use prompt. So now my prompt got updated. Then see, there are two things here. So there's this tools thing, which is basically like you can provide like access to key information. And then you have your knowledge, which is sort of your Foundry IQ, right? So I always recommend that obviously you can use tools as well, but you should also use knowledge, because in knowledge, like if you click here, you can connect to a lot of different sources. So this is my connection here that you see, which is this one. This is my search service connection in Foundry. And you can create like a new knowledge base here. So essentially have a nice knowledge base. So for example, if I create like a new base, oh, I will have to go. So if you have to create a new base, you can basically create using Foundry IQ. You can also create like a combined knowledge bases in Work IQ, Foundry, and Fabric IQ. So essentially make sure that you have done your data engineering, like the data structuring really, really well, so that your agent actually works effectively. And then create a memory store as well, so that your agent remembers. For example, here, by default, you can see there's one memory store I've built, but you can also create a custom one for yourself. And if I save this one and like maybe I try a few things. So basically this current agent is built for a marketing purpose. It's basically studying my campaigns for like different countries I'm currently working with. And it basically will give me any insight and statistics. Now, when I'm building this, like if I can test some examples and like give me some insight country in my campaign as well. For example, this is just like a question I've asked. So you see right here, it was basically giving me all these details. So you can see there are 3 countries here, India, Denmark, and Canada. So it will give me an outcome. It will give me all the key insight. It has taken my sort of like my data from my knowledge base. Now, I always recommend to create evaluations, because in evaluations, you can see how your
Sorry. My question is not about using LLM or agent for chat bot. My question
Hmm.
is more than using agent on production for doing some recommendation or action and for example, if I want to build like application to do on call, and when I have like some logs, incidents, the agent it will do give me it will take analyze these logs and give me some recommendation for example DevOps or ops to do some actions. Did you have been did you set up this kind of agents on production or what's your recommendations about
So, okay,
these steps?
so just to be very specific, so when we talk about setting up agents in production, you're asking about what steps you would want to take to make sure agents run effectively and they recommend you when they fail.
Exactly, yes.
Okay,
More,
so
more,
if
more, more than a chat or more about discussion. I want to see like agent on actions, taking actions from some use cases like incidents or
so
way.
Okay, so for example, like I worked on a voice agent project, and sometimes what it like does is like, for example, like when it fails to answer a question, it sort of so there's like a recommender system in the backend. So the recommender system starts to suggest what it should do, not do, or it will start to flag us, for example, or send requests that it is failing, right? So first thing it does is basically it sends us those requests that it is failing or it is not able to figure out or it hasn't got a user response. Second thing, what we have done is like create sort of like a verified checkpoint. When we talk about verified checkpoint, I mean not just the output that it does, but basically is the agent, does the agent perform in the required behavior that we expect it to? So for example, if there's an expected action that at that input that agent needs to perform, so there is like a the like I would say like a Boolean value in a way we have given. If that value does not show up, that means it will trigger us a reaction that okay, this is going essentially like wrong or like it's not performing well. And then like somebody from the support team will have to immediately look into, or we will get sort of like a trigger point that it needs to be looked into or rectified. So we have set up sort of like automated check-ins as well. But then in parts of the process, we have also like incorporated sort of like human in the loop where it's needed. So for example, if the same error comes, let's say more than two times, then like somebody will immediately go and check, because sometimes what we have seen is like once or twice it kind of fails on its own. So it was not really sort of like failing, but it was more like automatically timed out. So we tested a few times. So once it fails, I would say two times, we can go and check it. Like if it fails a third time, that okay, now there's some serious issue. We need to see what has happened. So it's more like what's the baseline? What's the baseline, the cutoff point that you would have that if my agent has ruled out all these XYZ possibilities, then this is the cutoff point, this is my baseline. And normally you will get them by testing on multiple business scenarios. So what you would do should do is you should create like a red team. Red teaming basically, which means you proactively like attack your own agent, sort of like try all these scenarios you know it can fail, to ensure that like you have covered as much as possible. And sometimes it's quite interesting because you will think of X scenarios and then you might actually come with X plus one scenarios as well. So this essentially makes sure that you are taking all those, if else conditions into consideration, where your agent might behave like out of scope, sort of, or like in a different way, right? I hope that answers your question, or is there anything more you want me to emphasize on?
I have another one. So when I want to use the agent in production, did you recommend me to use open source or public APIs like OpenAI, Cloud, or more to do fine tuning and using the model with solution fine tuned to control more the behavior of the models.
So, first, it's a good question. See, so there are scenarios. I think in some scenarios you could use, I would say, open model, but I think if I if I talk about current scenario that I've worked on, I mostly took like like I would say simpler version of the model, maybe like 4.1 or like 5. And then normally what I tend to do is like I would train that on my historical data, simply because in my current scenario, the use cases, that has been a better fit or the better approach. But I know that people have used, some people for their projects, they've used open source. However, I have not come across many scenarios where like it has been scaled a lot. So it's probably one of those cases that you might want to decide based on your use case. But in most cases, I would say like if you have predefined historical data available or any kind of use case, I mean, fine tuning does work quite well, or like, even building RAG actually works quite well. It's just more like understanding that, like, for example, if you are building an agent, firstly, what is the purpose of this agent and what do you expect to get out of it? Like, what's the outcome you're expecting from this agent? Are you thinking that it's going to solve your coding problem? Are you thinking it's going to solve your user problem? Are you trying to build like a customer agent? So I think firstly, getting from that point and then deciding which model you want to go for would be the right approach. And I think, like, see, fine tuning. This is the thing. I think fine tuning is good for specific use cases, which means you exactly know, very targeted, that what's the goal of your agent. If you don't know, then how will you fine tune it, right? You can't fine tune an agent like a model just like, hey, I want to fine tune it, right? You need to know, like, okay, I'm building this agent because it is going to build an application that is going to pay taxes. Maybe like that's a use case. You are trying to tackle the tax process for a public sector organization, something like that. So you need to understand that. And I think based on that, you can decide which you want to go for. You can use open source models. For example, the current architecture I am working on, I'm using, like, for example, smaller language models because those fit better, simply because they're easier for me to maintain at this point. But if my design or my needs for my product that I'm building changes, then I will have to think about how do I expand it, how do I change it. So think in the first lens about what's the trade-off you're making if you're using, let's say, if you're using OpenAI's model, or if you're just using directly available models, versus if you're performing like fine tuning on your model. So understand the trade-offs first, and that's how you can decide, like, for example, which model to prioritize while you're building your application. I hope that answers your question.
It's okay. Thank you.
Thank you so much for that powerful session. Thank you everyone for joining the session. So in the chat window, I dropped our meetup page. So we need your feedback. We actually value
Can
your
I ask
feedback.
another last question, please?
Yes, go ahead, Zaid.
I see many people hate RAG on this moment, because and they said always RAG is dead, RAG is dead. But how we do without RAG, how we can process without RAG? I think RAG is the most important part of building agents and behaviors, and without it we can't do nothing on production.
Yes, I think firstly you need to chat with people who are saying lag is dead. I know, so I have heard this line too. However, the interesting part actually, I would say, is like, for most of the applications, like RAG and fine tuning actually does still quite well. So I know people are saying that RAG is dead, and then we can use like this model. We can just go along with fine tuning and so on. But I think, like, see, as I said, like, you can use different approaches. It's more important to understand, like firstly, if people are saying RAG is dead, why they're saying it's dead? Is it because for their applications other approaches are working better? I think the second thing really is to understand that, like, for example, if for my current application the current approach works better versus a new approach, I would first try to see, the trade-off, as I said, like how this change will impact my current application, right? I will not go and make that change without considering all those things. So it's sort of very important to, before making those, I would say, assumptions or moving forward, understanding the gaps between the two processes. And if you think that RAG is probably something you don't want to use, and your model probably just gonna be better with fine tuning, or maybe just you can use a smaller language model or some other approach might work for you, or you have an open source model available that might cater to your need, then by all means you can feel free to do it. But I think it's super important to understand all the nuances before making those changes. And by the way, I've heard that too, and it's yeah, there is like a lot of discussion around it. But from most of the conversations I've heard, like a lot of people are still using Rack. I know some people are like saying it, but yeah, it's a topic which is which I would say is like it's being discussed. But yeah, I mean, unless you have a better approach, I would say you can use the old, like the version that is currently working for you. Is what I would say. I would do if I were in your position.
Thank you.
Thank you
Right. I
very,
think
thank you
yeah, I
so
think
much. Yeah,
I
I'm
was
not
gonna
sure.
say I might have to drop off now,
No worries, it's
unfortunately.
fine. It's fine. Thank you so much for the session. It's an amazing session. So please, guys, on the chat, we have links to our community meetup page. We value your feedback for the session. Please go there and provide the feedback for us. Then also, if you like to, volunteer for any of our sessions you like to speak, there's a session nice page that we've dropped in the chat. You can go there, drop your sessions. So we'll be glad to have you speak in our future sessions. Then we also have a page for our community code of conduct, as well as our community governance and operational processes. It's also available there. Then our social media, we are on Facebook, we are on LinkedIn, we are on Instagram as well. So feel free to follow us on those channels. Then I also dropped the LinkedIn profile page to our speaker for today. So feel free to connect with her. If you have other questions, you can always, DM her on LinkedIn and she'll be more than happy to answer those questions. So I want to use this opportunity to appreciate everyone once again for joining this session. We'll look forward to having you in our future sessions. Thank you so much and have a wonderful evening and a wonderful weekend. Bye for now.
Thank you, everyone.
Thank you. Bye.
Cheers. Bye.
Yes, bye everyone.
All right, guys. Thanks, guys. Bye.